Trusted Computing in Vehicular Ad Hoc Network, VANET. Second World Conference on Information Technology VIsit 2011. Second World Conference on Information Technology VIsit 2011. Trusted Computing in Vehicular Ad Hoc Network, VANET. Irshad Ahmed Isamra. isamra28@gmail.com. Global Journal on Technology. Volume 1, 2012, Introduction. Trusted Computing Group, TCG, is a non-profit group whose aim is to define a set of specifications that will create a trustworthy computer system with a trusted platform. The main idea behind these specifications is to enhance security in computer networks by using a security hardware module, called the Trusted Platform Module. Trust is the key security module of any system, and the TCG has defined trust as trust is the expectation that a device will behave in a particular manner for a specific purpose. Considering this definition in the context of VANET, it may be defined that all components of the network, user, vehicles and roadside units, are behaving in an expected manner. Trusted communication between the components and serve users through their safety and non-safety applications. The user, vehicle and RSU are the main components of a vehicular network, and it is necessary in a trusted computing environment that they behave in the expected manner and serve the user through safety and non-safety applications. Trusted Platform Module, TPM. The Trusted Platform Module, TPM, is the main component of the TCG specification, and it provides secure storage and resistance to software attacks inside the vehicle. Fig. 1 shows that each module of the vehicular network is embedded with security hardware module that is TPM, which would enable monitoring of the behavior of the vehicle and also roadside unit, RSU. General functionalities of a trusted platform. Hardware and software integrity. Confidentiality of data. Platform attestation. Attestation by TPM. Attestation to the platform, Vehicular Property-Based Attestation Protocol, VPP. Proposed protocol is also based on the PBA protocol, which provides attestation on some security properties in a vehicular environment. We view that attestation is critically necessary for vehicles and RSU trusted platforms. In this proposed protocol, the focus is mainly on properties, making attestation on the basis of the required properties only, which should be dynamic and may consist of security, trust or privacy properties. If users conform to the required properties for using the applications or services, then they would be allowed to become a part of the network and use the services. Internal attestation. A smart vehicle has many embedded sensors inside the vehicle, and it must communicate with and attest all sensors by using the TPM. Electronic Control Units, ECU, should be first attested internally, which assures its integrity for any changes its behavior using the TPM, and handles situations which does not conform to internal attestation. External attestation. If users meet the pre-service requirements of the property list, LP, as shown in given fig, then external attestation should be performed. External attestation is required when users send messages, to other users and also want to communicate with the RSU. Messages could be safety or non-safety, and the communication type may also change, that is vehicle to vehicle or vehicle to roadside unit, RSU. Our own properties list has been defined, and on the basis of this list, attestation has been performed while communicating with other vehicles or the RSU of the network. These properties are not static. They are dynamic, and government authorities of any country or any other vehicular authorized party can configure their own properties based on their own security, trust and privacy requirements. Proposed protocol features. This proposed protocol provides the following unique features. Roaming concept. In this concept, we assume users travel in their vehicles from one area to a different area. So it is necessary to provide applications and services in the new area, and the users must be accepted as part of the vehicular network. Malicious behavior. Attackers' dynamic behavior is a challenging task for other users of the network. Whenever users change their behavior, which can be a possible attacker, then their messages should not be tested. That is, if an attacker increase the vehicle's speed from some specific range, then it should be excluded from the network. Proposed protocol features. Communication in red zone area. Some areas are very restricted due to army activity, so local users cannot perform their communication in that red zone area due to security reasons. Only army vehicles can perform tasks in that specific region. VIP movement. Government vehicles and also any official visit of any official person in some city areas have the need for configuration of some different kinds of security properties, and local users cannot communicate with that specific group of vehicles. Proposed protocol features. Maintain the property list. In property lists, the features or behaviors of any component of the network can be included. When the platform of the vehicle is considered, then the software and hardware and other embedded sensors of the vehicle will also be considered, and their behavior will be checked related to any security policies. There are two types of properties defined here. Show the list of properties which we can change based on requirements. Static property list, LSP. It is a fixed property list in which all users are covered and can make communication between vehicles and also with the roadside unit, RSU. Government authorities are the ones who configure it and other users follow it. One copy of this list is copied onto vehicles. When they want to communicate with other vehicles or with a roadside unit, then this list is checked, and if they meet the requirements of the property list, they can perform their required task, otherwise it will not possible for them to do so. Proposed protocol features. Dynamic property list, LDP. There is flexibility for government vehicles, police, ambulance and army, to change their property lists according to the situation. Police make a plan to perform some operation against terrorists in some specific region, so they configure their properties in their group of vehicles to provide more secure communication between the users of those particular vehicles. Conclusion. Trusted computing ensures security and trust in a vehicular environment. The TPM is the key module of a trusted computing group, TCG, and plays a key role for the security of a platform. The attestation mechanism is to ensure the security of the platform, and the property-based attestation is one of the possible attestation mechanisms used to attest platforms on the basis of some particular properties. In this paper, a protocol has been proposed, and this protocol is based on the property-based attestation, PBA. The purpose of using this attestation method in a vehicular network is due to its dynamic behavior and the high mobility of the network node. More research is needed to define more security, trust and privacy properties for attestation purposes, and to make secure and reliable communication between users and with the infrastructure. As compared to the attestation method, the PBA is more suitable for a vehicular environment, due to its nature of being more complex. Configuration of the security properties, policies, will be a challenging task in different countries, and this task can be considered in future directions. Please download this research papers from ResearchGate and Google Scholar. Please share this video and subscribe the VANET channel, and don't forget to view the series of VANET videos. If you have any question, then email at the given email ID. Thank you very much for watching this video. Goodbye.